Alright, so let's go through this next problem. So a dragster starting from rest accelerates at 1.5 meters per second squared. How fast is it going when it has traveled 25 meters? Okay, so let's look at this here. Let's picture this. We have our car. It is starting right here. It is starting at here from rest, and it accelerates to 1.5 meters per second squared. Okay, so it's going to be starting over here, and it's going to go this much. How fast is it going when it has traveled 25 meters? Okay, so that's the situation. Let's start to plug in what we know. If it's starting right here, what are we going to say that the initial position is? Hey, this is getting a lot more common, right? We're going to see this a lot unless it really specifies what the initial position is. Okay, and what's the final position? Well, we know it has traveled 25 meters. Okay, so good indicator to us that that's our final position. All right, and what is this 1.5 meters per second squared telling us? Well, just right off the bat, being that we see the units of meters per second squared, we know that it's our acceleration. Never mind it already telling us that it's saying that's accelerating at this value. So let's just write that in 1.5 meters per second squared. Okay, this is another keyword right here. If it's starting from rest, hey, if it's starting from rest, how fast is it initially going? Okay, and what is the problem asking us for? How fast is it going when it has traveled this much? Okay, so how fast is it going? Oh, that's our final velocity. That's what we're being asked for. And do we care about our time? Does it tell us anything about time? No. Do we care about time? Is it asking us for time? No. Okay, so that's the thing that we don't care about. All right, so we don't care about time. Well, okay, so are we dealing with average velocity? No, right? It said nothing about average velocity. We're not trying to solve for average velocity. So we know right off the bat that we're going to be dealing with these four formulas down here. Once again, we don't care about time. So wherever we see time, we're just going to say, hey, you know what? I don't care about time. We're not using that formula. What about this one? Do you see time? Okay. Oh, there it is. All right. I don't care about this formula. What about this one? Oh, we got time here. Oh, you know what? We also have time here. We're definitely not using this formula. Hey, I bet we're going to be using the last one. Do we see time? Nope. Good indicator to us that we're going to be using formula number 6 in order to solve this problem. So let's write that out right now. So we have VF squared is equal to minus XI. And always, always, always double check to see that you actually wrote in the formula correct. Okay, so I believe I remember writing that incorrectly. That would be an awful mistake to make, and I've seen students actually do that where they forget, hey, you know what? It's very easy to forget these squareds over here, or instead of writing a minus sign, I've seen people actually write a plus sign in here. Maybe they'll write a minus 2a over here. Either way, make sure that you write the formula correct, because it would just be such a silly mistake to get the problem wrong because you wrote the formula wrong. All right, so let's do our substitution now. What do we have? VF is what we're trying to find. So we're just going to drop this down. VI squared. Okay, so we have 0, and we're going to square that number. We know that 0 times any number is equal to 0, so that's not going to do anything for us. So we have 2 times our acceleration minus 0. Okay, and let's just continue to solve this out. Provides no value. That provides no value. Essentially, that's what we're doing, right? All right, great. So we have VF squared is equal to 75. Hey, you know what? I want the velocity. I don't care what VF squared is equal to. So how do we get rid of the squared? We take the square root. And that will get us our final answer of 8.6 meters per second.